Right, so let's have situation 8. Still structural engineering and construction. Or ngayon, this is the principles of structural analysis and design. Ito yung problem natin, situation 8. So refer to the figure below. Ito yung figure na binigay sa board exam. Then actually meron ding code na binigay pero hindi ko na lang in-include dito, no? Kasi simple lang naman yung code natin sa shear strength of concrete. So beam section given, you have beam section of for beam AD, PE, and CF 250 by 450 mm. Ito yan. You have AD, PE, and CF. These are beams. Ito naman, girder. You have girder sections for the girder ABC, ito, and DEF. Dimension is 350 by 600 mm. And you have the S, itong dimension S is 3 meters and length is 6 meters. Then we have the concrete cover to centroid. Centroid of the reinforcement, 70 mm. Then concrete compressive strength, FC prime, and you have the FY, reinforcing steel yield strength, FY. And dead load is 5.5. You have this is already included the beam weight. Dead load including the beam weight. No, naka-indicate talaga siya sa board exam. Live load for all spans 4.8 kilopascals. By the way, the loads given are in terms of pressure. So we need to convert that one later, no? Then required strength 1.2 dead load plus 1.6 live load. So this is NSCP 2015. Reduction strength reduction factor phi 0.75, that is for shear reduction factor. For this situation, yung ating problem is all about shear capacity. No, shear strength of concrete, not capacity. No, shear strength provided by concrete. Basta all about reinforced concrete shear failure. Okay, so lagyan muna natin ng values. Yung L and S, L is 6, L is 3 meters. Lagyan lang natin ng values. Then, the beam AD, BE, CF. These are 250 by 400. No? But, as you can see here sa problem, yung ifo-focus natin is actually the beam BE. BE. Beam BE. Beam BE. No? So, finocus ko lang dito yung ating beam BE. AD, CF is also equal to 250 by 400. Alright, anyway, yung ating girder AC, and ABC and DEF, they are 350 by 600 mm. Again, ito yan. Okay, after that, let's solve the problem. No? So, which of the following gives the critical design shear stress? Shear stress in beam PE. Hindi siya shear strength in kilonewtons. Naka-indicate pa yung ating unit. Shear stress dapat. Ano yung gagawin natin? Okay. So, we are to consider the beam BE. So, kailangan natin makuha yung load na nag-act sa beam BE. No? Yung load na nag-act sa beam BE. So, let's isolate that beam. That one. Let's say that's the beam BE. Yung load natin will be uniformly distributive load. Kasi yung gagawin natin is, we'll be assuming na tributary area yung i-carry niya. And most likely, yan talaga yung gagawin natin, no? Kasi sa design, tributary yung i-carry ng ating beam. Ano yung equivalent area na kanyang i-carry. So, this is our WU. So, tawagin nating W for factored na may subscript na U. So, yung gagamitin natin, yung length ng beam is the, kumbaga, clear length natin from the face of the support. These are the girders. Support yung girders natin dyan. Tawagin nating LN. Yung 6 meters is center to center yan of the girders. Alright, then yung gagamitin natin na length, tawagin natin LN, that will be 6. Kalahati ng, take note, this is girder, 350 yung kanyang width. Kalahati dito 350, kalahati dito 350. So, i-subtract natin kalahati ng 350 and kalahati ng 350 on the other side. Basically, that's a total of 350 millimeters. In meters, that's 0.35 meters. So, yung length na gagamitin natin is 5.65 meters. Now, take note, kung yung gagamitin mo, kung magkamali ka sa length na gagamitin mo, say for example, 6 yung gagamitin natin, may lalabas pa rin sa choices. Ganun ka-critical yung choices ni examiner natin sa structural. Okay, so 5.65 yung ating length for beam BE. So, as you can see here that, of course, we need to calculate the W, no? Pero yung analysis natin to calculate the design shear stress in megapascal, kukunin natin yung critical shear strength. So take note, as you can see here, by symmetry, even though walang binanggit dito kung naka-fix siya dito, or magre-resist ba siya ng torsion, no? But based on shear lang yung ating analysis, it is always, as you can see here, by symmetry, the reactions here at the ends are always equal based on this figure, no? By symmetry. RU yan, let's say that is also RU. Again, kahit na naka-fix yan, hindi yan magmamatter sa shear diagram natin, no? Kasi kung i-plot natin yung shear diagram, alright, if these are equal, so yung shear natin dito is equal to RU. Okay, then uniformly distributive load, bababa yan linearly, negative RU naman dito. So this is our shear diagram. Again, hahanapin natin yung critical shear strength, and that is according to the code, that is that can be taken at a D distance from the face of the support. Yung D na yan is the effective depth of the beam. Okay? Dito natin hahanapin yung ating critical shear stress. Critical shear force. But before we calculate this one, the VU, we need the WU, the factored load in kilonewton per meter. No? Kilonewton per meter. Take note, yung givens dito, yung givens are naka-kilopascals or naka-pressure. So we need to convert these loadings into a kilonewton per meter for linear weight. Alright, how do we do that? So yung W will be using this combination, load combination, given siya 1.2, 1.6. Right? So that is 1.2 W dead load plus 1.6 W live load. Okay. Now, gagamitan natin ng tributary area. Bali, yung i-carry ng beam BE is ito. Kalahati ng 3 dito. Ito. Kalahati ng 3 meters. Here. Kalahati ng 3 meters. And kalahati din ng 3 meters on the other side. So, overall, a total distance of 3 meters lang din. Actually, merong another possible option dito, no? Another possible solution ng examiner. That is yung i-distribute natin siya by 45 degrees dito. Pwedeng ganyan. Pero as I solve this one, using this tributary area method, na kalahati by kalahati dito, may lumabas sa choices. No? Kaya, kung tatanungin niyo ako dito, depende talaga yan. Depende yan sa examiner. Pwede naman sadyain na ganito talaga yung distribution niya. Bale, yung makikerry ng beam BE is a trapezoidal loading. Pwedeng ganyan. Pero, again, depende talaga yan sa designer. For this problem, trinay kong gamitin ito, then may lumabas sa choices. Kaya, I'm sure na ito talaga yung ginamit ni examiner. And kadalasan naman, ganito yung ginagawa niya. Pero may time na lumabas talaga na ginawa niya trapezoidal loading yan. Which is ganito yung ating pag-design. No? Again, walang mali dyan. Actually, mas, mas conservative pag ginawa natin yung trapezoidal loading. Kasi as you can see dito, No? Buong rectangle yung ating kinuha. Mas safe siya pag ganito yung ginawa natin. Well, whereas kung ginamitan natin ng yung 45 degrees distribution, wala itong triangle niyan, no? Hindi siya makikiri ng ating beam BE. That means, kung ginamitan natin dito, mas in-expect natin na mas marami yung kinikerry ng beam BE. Okay, anyway, again, ito yung ginamit ng examiner sa problem ito, no, for this board exam. So, 1.2, take note the dead load given is 5.5 kilopascal. So, 5.5, i-multiply natin ng tributary width para maging kilonewton per meter siya, no? Para maging kilonewton per meter. Take note, kilopascal is kilonewton per square meters. Then, nag-multiply tayo ng 3 meters. Cancel. So, magiging kilonewton per meter yung unit dyan. Then, sa dead load naman, sa live load, 1.6, 4.8 kilopascal. Same tributary width na 3 meters. Then, the WU is 42.84 kilonewton per meter yung ating unit. So, as you can see, yung ating RU that is equal to the total force, downward force or downward load, no? Or that's the resultant of W divided by 2. Kalahati lang. Yung RU by equilibrium is equal to W times ln. That's the total reaction divided by 2. And we will have, substitute natin, ln over 2, RU is 123.02 kilonewtons. Again, yung ating critical shear force is taken at a D distance from the face of the support. Ito yung face ng support natin dyan. So, to calculate that, gawin na lang natin yung area method of the shear diagram. Alright, so the change in shear is equal to the area under the 2 points. Under these 2 points, the area of the loading is ito. So, from RU tayo, minus, kasi yung loading natin is pababa, so minus the area of the loading is W times T. So, we have RU, 123.02, then minus W 42.84 times D. Okay. Saan ba natin nakuha yung D? Alright, pakita lang natin. So, makukuha natin by the way na VU is 106.88 kilonewtons. Again, ito yung ating D. Yan. Saan natin yan nakuha? Na kung titingnan natin yung beam BE, ito yung beam BE natin, 250 by 400. So, 250 yung width, 400 yung total depth. Ito yung ating VU. That is our VU, nag-a-act sa ating section. Alright, suppose ito yung ating AS. Take note, the effective depth of the beam is from the farthermost, extreme fiber to the centroid of the reinforcing bar. So, walang binigay na ilang reinforcing bar, assuming AS. Then, binigay itong dimension na ito. Concrete cover to the centroid of the reinforcing bar. To the centroid yung binigay. Hindi niya sinabi clear concrete cover. So, automatic to this centroid. So, if we have this dimension, then the effective depth is 400 minus 70. So, we will get 330 millimeters. So, that's why, yung D natin in meters, 0.33 meters. Okay? But hindi ito yung hinahanap, no? That's the shear, critical shear force on the beam. Gusto natin dito, critical design shear stress. And take note, naka-indicate design shear stress. Ibig sabihin dyan, factored yung kukunin natin. Kasi pag sinabi niyang nominal, then yung kukunin natin is nominal. I-divide natin ng feet. So, take note, shear stress is force over area. Yung area natin is the effective area. B times effective depth. B times effective depth. So, yung ating VU of force over the area, VU, gawin natin siyang newtons. 106,880 newtons divided by the area. So, 250 by 330. Ito yung makukuha natin, 1.29 megapascals. So, sa choices, yung answer is letter B. Now, again, napaka-critical ng mga choices niya. Kasi kung i-divide natin yan ng phi, for example, nagkamali ka, kita natin sa calculator. Alright. Pag dinivide natin ng phi yung 1.29, take note, reduction factor for shear, and that is also given, is 0.75. May lalabas sa choices dyan. That's 1.72. 1.73. No? Ganun siya gumawa ng choices. Napaka-delikado. And aside from that, pag yung ginamit natin na L dito, for example, nagkamali ka dito, yung ginamit mo is yung 6, meron pa ring lalabas. I have the solution dito in MathCAD. No? I will show you that one later after we solve the other problems. Okay? Next question. Which of the following gives the shear strength VC? Shear strength VC. Take note ha, VC. Naka-indicate talaga VC. Provided by beam BE. Ganun pa rin, beam BE. So, let's say ito yung ating beam. Okay. Nilagyan ko na lang ng rebars. Wala naman siyang binanggit dyan. Nilagyan natin ng rebars. So, sa code, again, binigay yung code dito, but you need to familiarize this one kasi sometimes hindi siya binibigay. Familiarize natin. This is for NSCP 2015. So, assuming normal weight of concrete, so lambda is equal to 1 kasi wala namang binanggit. Parating 1 yan, basta hindi babanggitin, no? 0.17 times 1 lambda. FC prime, so given FC prime dito. FC prime is 20.7. Okay? So, BW is the 250. Yung depth is 330. Then, you will get value of in newtons, in kilonewtons, 63.81. Answer here is letter A. Now, BC. Now, kung nag-multiply ka dito ng reduction factor, meron pa ring lalabas. Grabe si examiner. Napakatyaga gumawa ng choices, no? So, 63.8 times 0.75 reduction factor. Ay lang yan. 47.85. Look. It is here. 47.85. So, itry na natin i-divide naman si reduction factor. May lalabas ba? 63.8 divided by 0.75. Tingnan natin. 85. Wala naman. Okay, so take note, pag nilagyan natin siya ng phi, design shear strength of concrete yan. Dito indicate talaga VC lang, shear strength VC. So walang phi yan dapat. Okay? So madali lang yung number 23. Yung number 24, madali lang din. The shear reinforcement of BE, o beam BE, consists of two legs of 10 mm diameter bars spaced at 150 mm center to center. How much is the resulting shear strength VS in kilonewtons? VS lang ha, walang phi. So, consists of two legs. So, ito yan. Use stirrups. Okay? So, wala siyang cross ties dito sa gitna. Use stirrups lang kasi two legs. Again, assumption lang ako lang dito yung number of bars. Now, titingnan natin sa 3D. Yung spacing na sinasabi dyan is the spacing of the ties. No? Lateral ties. So, again, sa code, ito yan. VS is AVFYT times D over S. Alright? So, ano yung ating AB? So, take note, titingnan natin for the AB, ilang ties yung mag-support sa ating load VU. Ito, dalawa. Again, kung may cross ties yan, then tatlo. Again, tingnan mo lang ano yung kukontra sa ating shear force from the load. This is from the load, no? So, dalawang 10 mm yan. Dalawang 10 mm. AB is pi over 4 times diameter squared times 2. Again, kung may cross ties yan, bilangin mo lang ilan yung kukontra dyan. Itong dalawang forces. And you have 157.08 square millimeters. Okay. So, direct substitution, we have FYT. So, sa board exam, FY yung binanggit niya dyan, 275. So, wala namang ibang FY na binanggit. So, assuming this is already the FIT. And 275 ang value dyan. So, most likely para sa ties talaga ito. Hindi siya para sa main bars. Alright. So, VS equal to AB. FYT is 275. Effective depth is 330. The spacing is given 150 center to center. And ito yung makukuha natin exactly. 95,033.4 newtons or 95.03 kilonewtons. Sa choices niya, 95.6. So, wala namang ibang pwedeng gawin dito na magbibigay ng other values dyan, no? I-try na natin siya i-multiply ng phi. Kasi may mas maliit dito sa choice. Ano yung lalabas kung nag-multiply tayo dyan ng phi? Okay, let's try. You have 95.03 times 0.75. We have 71.27. Meron pang 71.27. So, cannot be. Hindi rin pwede. Kasi, anyway, VS yung binanggit niya, hindi phi VS. Ito lang yung VS. According to the code yan. Most likely, baka nagkamali lang dito sa ating tawag dito. Numbers dyan, no? Yung pag-type. So, yung answer ko dyan is 95.6 or letter D. Okay? So, actually, meron pa tayong i-check dito. Itong code na ito. We need to check this code. Check if VU does not exceed phi BC plus 0.67 FC prime BWT. So, actually, itong term na yan, ito yung limiting value of the VS. Kasi sa 2010 na code, hindi siya ganito pagkasulat sa ating NSCP. Yung tawag dito, ginagawa natin, kino-compare natin si VS sa 0.67. So, why not i-check na lang muna natin yung VS. Diretso na. Huwag na natin galawin yung BC at BU. Okay? Check if VS is less than this term. Substitute natin. Then, take note, yung VS is 95,033.4. 95,033.4 yan. 4 newtons, hindi yan 0.5. Okay. And yung term nito, calculate that one, 251,486.21 newtons. So, okay naman siya. Ito yung duda ko kung wala talaga exactly ito. Kasi, pag bumaliktad to, say for example, mas malaki ito compared sa ating limiting value, yung gagamitin, most likely yung gagamitin natin dyan, ang gagamitin ng examiner as answer is yung limiting value niya. Again, kung kunwari lumagpas yan, no? Let's say for example, nasa 80,000 lang to, newtons. Gagamitin natin is 80,000 newtons. Pero masyado namang malayo. So, yung sagot talaga dito is letter D. Pagka sa rounding off lang yan, nagkatalo. Okay? Alright, so, makita natin yung ating MathCAD program dyan sa solution for this problem. I have it here. Yeah. Ito. So, nilagay ko na yung mga givens. Yan. Again, ito yung makikita natin kung bago-baguhin natin yung values. For example, ito yung ln. For example, yung L na 600 talaga yung gagamitin natin. I mean 6 meters. Ito. if L is 6 meters, hindi LN yung gagamitin ko. Yan. Then, lagyan ko ng P dito. Ilalabas, ilalagyan natin ng P. You have 1.84. That's number for the first problem. Ito yung sa first problem. So, 1.84 or 1.85. Alright. Anyway, yung mapapile natin dyan, talagang need natin ng principal. So, that's it for this situation.